In this video, you will learn what is the concept of balance section, what its diagram, and how you find the moment of resistance. Hello friend, I'm Saumadeep back to a new tutorial video regarding RCC. In my last video, I talked about some design constant value. In case you missed this video, then definitely you click on this I button. Otherwise, you go to the playlist section and check the last video. So without further delay, let's get started the balance section. Before starting the concept, first I want to say something that say this is your beam cross section, and here the strain diagram, and here your stress diagram. So suppose t equal to 0, there is no strain, but t equal to t, then in compression there will be a strain generated. In tension there is such kind of tension. So here is three chance of possibility. Possibility number 1, strain or stress generates at same time. That means at same time when the compressed fiber reach its maximum strain, in tension zone they reach their maximum tensile strength. Number 2 situation, strain or stress in compression zone occur first, then tensile zone. 3, strain or stress tensile zone occur first, then compression zone. So these are the probable 3 scenarios. So based on 3 scenarios, there are 3 conditions. One is your balance section, another is under reinforcement section, number 3 is over reinforcement section. Okay, these are the 3 scenarios. So in this video, first we discuss the concept of balanced section. So in balanced section, stress occurs in 2 zones, that is compression and tension at same time. Okay, so what you write in exam? A balance section is a section where stress in concrete, that means compression zone, and steel, that is your tensile zone, reach their permissible value. I make a separate video of what do you mean by permissible value in case you didn't watch or you missed. My humble request is go and check out permissible value at the same time. And in this section, neutral axis known as critical section. Okay, so now we design the or we draw the diagram. So here this is your a beam cross section, and I'm assuming that this is your neutral axis zone. So in balance section, what happened? In balance section, this. And this is your neutral axis. This is known as your critical neutral axis. That's it. This value is your n. This whole value is d. So this value is your n minus d. This is the diagram. Now we find moment of resistance. So what is the moment of resistance? The moment of resistance equal to either compression or tension. As in the balance section, I mentioned here, same time. So either you may write m of c that equal to m of t. So either moment, so m are equal to sigma cvc by 2 b nc d minus nc by 3, or you can say sigma st ast d minus nc by 3, where sigma cvc is the permissible stress of concrete, b is the breadth of the beam, nc is the neutral axis, d is the effective depth, ast is the area of steel, sigma st equal to your permissible stress of steel. Okay, fine. Okay, fine. And how you find the critical neutral axis? Neutral axis or critical neutral axis. So m sigma cbc divided by sigma st equal to nc by d minus nc. So from here you can write nc minus d n sigma cvc nc sigma st. So that n sigma cvc d that is equal to n sigma cvc minus sigma st. That is the value of the nc. Yeah, this is how you may find the value of critical neutral axis, and this is how you find the moment of resistance. So yeah, this is a very short and simple video regarding balance section, where I discussed the concept diagram, moment of resistance, as well as how to find neutral axis. So yeah, if you have some query, doubt, or if there's some problem, let me know in comment section. I will very much grateful to answer all these your doubts. And yeah, if you find some value from this my video, then definitely like the video and circulate this video to your friend circle. And yeah, for more this kind of content, so definitely do a like and subscribe this channel. Yeah. So yeah, thank you for watching this video. In next video, we will talk about the under reinforcement section. And yeah, thank you for watching this video. Until then, bye bye. Take care. See you soon.